Good afternoon, everybody. My name is Jared Rowan, and today I will be discussing significant figures. What are significant figures, why we use them, and why they're so important. So what are significant figures? Significant figures are the digits considered reliable as a result of measurement or calculation, not to be confused with the number of digits or decimal places. Those are just simply the number of digits to the right of a decimal point. Adding to what's important about significant figures are that all digits other than 0 are automatically considered significant. Why are significant figures important? Well, the idea behind significant figures is when doing a computation that you are not over-representing the amount of precision you have, that the result isn't more precise than the things you're measuring and use to get that result. How can a result be more precise than what we are measuring it with? Here are just some rules for significant figures. 0 is only significant when it appears between two non-zero numbers, or it is a terminal 0 and a number with a decimal point. 0 is not significant when it is used to fix a decimal place, or when it is used in integers without a decimal point that could be expressed in scientific notation without including that 0. And of course, all whole numbers by themselves are significant figures. So here are just some examples of when 0 is significant and when 0 is not significant. So if we just look at this first example, 306 has 3 significant figures. We count the 0 as a significant figure because it is in between two non-zero numbers. If we look at this one too, it has 4 significant figures, 5.006. We count the zeros as significant figures because, again, it is in between two non-zero numbers. We look at when 0 is not significant. 0.0456 has 3 significant figures. Why? Because this 0 is used to fix the decimal place. And then if we look at this one down here, 2000 has only 1 significant figure because it can be used in scientific notation as 2 times 10 to the third. Same goes for 3000, 35,100. It has 3 significant figures because it can be expressed in scientific notation as 3.51 times 10 to the fourth power. Some calculations. A quotient or product should contain the same number of significant figures as the number with the fewest significant figures. Exact conversions do not affect this rule, and the answer resulting from addition or subtraction problem should show significant figures only as far to the right as the least precise number in the calculation. For addition and subtraction operations, the least precise number should be that containing the lowest number of decimal places. So we just look at some examples here. We have 2.43 times 17.675. It equals to 42.95025. So we look at this 2.43. It only has 3 significant figures, and 17.675 has 5 significant figures. The answer should be rounded to 43.0, so it has 3 significant figures, and that just shows that this is the least precise, so we use this 43 points. So we use 3 significant figures. And then if we look at this next problem, 2.479 hours converted to 60 minutes equals to 148.74 minutes, which we would put as 148.7 minutes. As you can see, 2.479 has 4 significant figures, and 60 minutes per hour is an exact conversion. So again, we would put the answer as 148.7 as it contains 4 significant figures. So now we look at some adding and so we look at some adding examples. We have 1,725.463 plus 489.2 plus 16.73 is equal to 1,931.393. 489.2 is the least precise because it only has 1 decimal place after, and this example has 3 decimal places right here and 2 decimal places right here. So we use the least precise, and the answer should contain only 1 decimal place. So we round that off to 1,931.4. And we look at this problem right here, 903,000 plus 59,600 plus 104,470. It equals out to 1,067,070. And we look at this, 903,000 is the least precise number because it only contains it has zeros right here, so that is the least precise number. The answer should be carried out to the thousandth place, so the answer would be 1,067,000. Alright, so rounding. If the most significant figure dropped is 5 or greater, then increase the last digit retained by 1. So we look at this 43.48 rounded to 3 significant figures would be 43.5. How do we know this? We look at this 8 right here, and it's greater than 5, so we would round the 4 up 1 by 1 and make that 43.5. And if you look at all these other examples, it would show the same thing. Rounding values and calculations. So in general, it is neither necessary nor desirable to round intermediate values in calculation. If you do, maintain at least 2 more significant figures for all intermediate values than the number you plan to use in your final result. The following demonstrates the risk of excessively rounding intermediate results. So we have this, so we evaluate C is equal to 10,000 times 0.6 minus 5 divided by 9 plus 0.044. If we use a calculator with no intermediate rounding, the answer C would be equal to 4.4. If we rounded values within the parentheses to 2 significant figures, so if we look at this right here, the answer would be 0.599555. If we round that to 2 significant figures, it'd be 10,000 times 0.6 minus 0.60, which C would equal to 0 then. And if we rounded 5 divided by 9 to 2 significant figures, it'd be C is equal to 10,000 times 0.6 minus 5 divided by 9, which is 0.555 plus 0.044, which is equal to 10,000 times 0.6 minus 0.56, could be round 5 divided by 9 to 2 significant figures, which is equal to 0.56 plus 0.044, and that would equal to 10,000 times 0.6 minus 0.604, and C would then equal to negative 40. So you can see the risk when you round intermediate values within the calculation. So you need to be sure you understand what you're doing there. And I think the most important aspect to take from this is why significant figures are so important, and the idea behind significant figures when doing the computation, that you are not over-representing the amount of precision that you have. The result isn't more precise than the things you measure and use to get the result with. I think that's the most important thing to take out of this. So I hope you like this demonstration about significant figures as much as I liked putting it together. So thank you.